everyone, welcome back to Introvex, your robotics guide to excellence. This video is the start of our brand new series, Build Your Chassis. If you've ever wondered how to make your robot chassis sturdy, smooth, and fast, you're in the right place. In this series, I'll walk you through key ideas that can really boost your design and talk about the fundamental building tips so you can understand every move. So in episode 1, we're diving into something fundamental but powerful, which are gear ratios. So let's start with the most common question being asked. Why do we care about gear ratios? Gear ratio is basically the choice you make that defines whether your robot focuses more on speed or torque, or it may try to balance both. Also, gear ratio may come in handy when the motor RPM, which is revolutions per minute, is different from the speed or RPM you intended to create. Let's first take a look at the starter kit robot, for example. When you build your first robot, maybe using the VexIQ Super Kit or Competition Kit, you'll probably build the above robot. On the left, it is the second generation education kit chassis. And on the right, it is the first generation kit's Clawbot chassis. And comparing the two, you'll find some difference. So first, on the left, the motor connects directly to the wheel, and the second wheel is not powered by any motor. So this is what you'll first have to avoid when you create a chassis. You will have to avoid having wheels with no motions to rotate, which is the second generation kit robot's chassis. And instead, you should attach another motor to the wheel or connect two wheels with gears. This makes both able to rotate with the motor power, and it will not being dragged on the surface. So the correct example would be the first generation Clawbot. It connects two wheels with 36 tooth gears, and this makes both wheels rotate at the same rate. Moving on, we'll talk about how to calculate gear ratio and what it is. What exactly is a gear ratio? It's the ratio between the output gear, which is the one that drives your wheel, arm, or other mechanisms, and the input gear, which is the one that the motor turns. In our Clawbot, the motor's 36-tooth gear is the input, and the other 60-tooth gear is the output. Sometimes there is an extra gear in the middle, which is shown gray on the picture, that is called the idle gear. It helps with spacing, but it does not change the actual gear ratio. So in this case, to calculate the gear ratio, we divide the output gear's teeth by the input gear's teeth. So in the Clawbot, it's 36 to 36, or just 1 to 1, which the gear ratio is 1. Okay, so here's a fun challenge for you. Check out this setup. Can you spot the input, idle, and output gears, and also calculate the gear ratio? Alright, I'm going to reveal the answer. Ta-da! The input gear is here the 12-tooth gear, which is driven by the motor like we said, and the output gear here is the 48-tooth gear, which drives the wheel. And others are idle gears, including the 60-tooth and 24-tooth. So the gear ratio would be 4 by dividing the output gear by the input gear. Moving on to part 3, I hope you understand now how to calculate gear ratios. Now we're moving on to common competition gear ratios. In VexIQ, most competition chassis aim for faster speeds, in other words, a lower gear ratio. For example, the most common ones are 1 to 2, 1 to 1.5, and 1 to 1. And 2 of them are for increasing speed, while the other 1.1 gear ratio doesn't change the speed. So you can think of some possible gear combinations right now as a quiz. So yeah, think about it. Are you ready? Okay, so in Super Kits, there are only 3 sizes of gears included, which are 60-tooth, 36-tooth, and 12-tooth. If you do a little calculation, it is impossible to create the above 1 to 2 and 1 to 1.5 gear ratios using only the 3 sizes. And also, 60-tooth gears cannot be used in the chassis because it has a greater diameter than most commonly used 200mm travel wheels. And note that the 200mm wheel does not mean the radius, but actually the perimeter. So if you do a calculation, you will know that the radius is about 3.183 centimeters. And see at the left hand side, you can see that the gear is actually larger than the wheel. That's why if you want to connect wheels with motors through gears, you'll have to purchase the gear add-on pack containing 24-tooth gears and 48-tooth gears. Or you'll have to use sprockets or pulleys, which we will talk about in our next episode. With 24 to 48 or 12 to 24, we can generate a 1-to-2 gear ratio, making the wheel spin twice as fast as the motor's rotation. However, 12 to 24 is not recommended because in this case, on the left-hand side, you can see that both the gears are too small and you have to use additional gears to separate the wheels, like the picture indicates. You can see that the 24-tooth input gear is blocked by the wheel. There is no hole to connect motor. Moving on to the 1 to 1.5 gear ratio. It can only be accomplished with 24 to 36. This might require some more complicated connection methods since the wheel covers the center of the 36T gear when aligning both gears side by side with 24 tooth attached to the wheel. Showing above is my chassis during the slapshot season, and you can see that I used idle gears between the input and output gear to do the work. And you can also connect the motor to the center gray 36-tooth gear. That will also make a 1 to 1.5 gear ratio. But in this case, since I need the space there, so I connected a extra input gear on top. Next, a 1.1 gear ratio is very simple. You just have to use two same teeth gears as output and input. An additional gear ratio possibility is 1 to 1.333333 infinite threes, using 36 to 48 gears. This provides a little more speed while not alternating the motor torque that much. So you may also consider this gear ratio. Alright, let's move on to our last part, which we will talk about speed and torque. Now, I'm here to answer the question of what's the difference between the gear ratios? Aside from changing the output speed, gear ratio also changes the output torque. But what are speed and torque? Simply saying speed is how fast the chassis can go and torque is how strong the chassis can resist, which torque is inversely proportional to the change in the output speed. That means that if you have a 1 to 2 gear ratios, your speed will double but your torque will half. And oppositely, if you have a 2 to 1 gear ratio, you'll have double the torque and half the speed. So let's use gear ratios we talk about as an example to calculate the speed and the torque of the chassis. But before calculating, we have to know that VEX IQ Smart Motor spins at 120 RPM and it has a stall torque of 0.414 Newton meters, meaning the motor can resist 0.414 Newton of force at a 1 meter distance. An easier way to think about the relationship is that the larger the motor gear is than the wheel gear, the higher the speed and the lower the torque. So for example, on the left-hand side, you have a 1 to 2 gear ratio, then the speed will be 240 RPM, which is doubled. And for the torque, it'll be multiplied by the gear ratio, which it will be multiplied by 0.5, which halves the torque. After filling in the calculated speed and torque, we can see that when speed is multiplied by the torque, it equals to the original speed multiplied by torque, which is 49.68 right now, which this is an evidence that both are inversely proportional relationships. But then you might have the question of speed difference can be observed, but what does torque do? Basically, torque determines the maximum weight the chassis can handle before the motors stall. So if your robot is too heavy or faces too much resistance, and your motor torque isn't enough to handle it, your robot will slow down and maybe not move at all. We'll dive into the detailed calculations in the future, but for now, just remember that high speed is not always the best. You'll have to consider how much structure you put on the chassis. So for now, you might have to consider which gear ratio to use for your season. For higher speeds like 1 to 2, it can be used when there are less obstacles, larger space, or lighter robots. For moderate speed like 1 to 1 or 1 to 1.5, it's when you have a heavier robot and carry a lot of game objects. So let's see some examples from the previous seasons to help you understand. On the top left, it is the slapshot season, which you can see we only have to control half of the field, and there are a lot of obstacles on that half as well. So at the time, I chose 1 to 1.5 gear ratios as I still need some speed. And for the top right, which is the rapid relay season, we can see that there is a large space and all you have to carry is maximum 2 balls. So you can create a really hollow robot or whatever. This means that you can drive very fast and that will still be okay. And for this year's season, you can decide. If you think that you can aim really precisely and move around really easily, if you have really good control, then you can go with the 1 to 2 gear ratio. But if you think that there are too many game elements and I will probably have a really trouble time on aiming, then you can first try the slower one first, and maybe if you practice a lot, you can try the 1 to 2. And that's it for this episode. So I really hope you learned something from this. If you still have any uncertain or something that you don't understand, please comment down below and tell me where I can probably explain in more detail. So in our next episode, we'll cover sprockets and pulleys and how they connect our chassis in different ways. So this is Intervex, the robotics guide to excellence, and see you next time. Bye bye.